for the guided assessment is Zach was waiting for his friends at the cafe. He started playing with toothpicks at the table and made these patterns. How many toothpicks are needed to make pattern 6? All right, so on my paper, I am going to make a T-chart, and I'll flip back over to my paper in just a second. On one side of the T-chart, we are going to have pattern. And then the other side, we will have toothpicks. So I have pattern 1, 2, and 3 on the screen. And pattern 1 has 4 toothpicks, 7 and 10. And we want to know pattern 6. All right, so this is what I have on my screen so far, or on my paper so far. So since we want to know how many toothpicks for pattern 6, it's probably just going to be easiest to continue with the T-chart. So I'm going to go 4, 5, 6. So remember, guys, if you want points for this guided assessment, you need to have everything written down that I have down on my paper. And then you can submit your notes for points. Okay, so I can see over here that I am adding on 3 toothpicks each time. So after 10, if I add 3 toothpicks on, I've got 13, 16, 19. So for pattern 6, we'll have 19 toothpicks. All right, let's go to question 2. What the heck did I do? All right, for question 2, we have Zorkian Zyders. Always grow a single hair from each body segment, including the body. Assume the Zyders continue to grow in the same pattern. How many hairs would the 5th Zyder have? Okay, I'm going to do another T-chart where I have Zyders and hairs. We want to know the 5th Zyder. So on the Zyder side, I'm just going to count 1, 2, 3, 4, 5. And on the hairs side, I've got 5 hairs for the first one, 2, 4, 6, 8, 9 hairs for the second one, 3, 6, 9, 10, 12, 13 hairs for the third one. So on my paper, I've got going from 5 to 9. We're adding 4 each time. So if we add 4 to 13, 17, and then 21. So we wanted to know the 5th Zyder. It has 21 hairs. All right, for number 3, okay, complete the table to show the number of hairs on a Zorkian hairy Zyder. All right, well, we already went up to 5. We need to know about the 10th one. So I am going to do this one a little bit differently. All right, for the 10th Zyder, we know that each Zyder, or each month a Zyder grows, it adds on 4 more hairs, except for this very first month that has 5 hairs. So if we want to get to the 10th Zyder, and it's increasing by 4 each time, we can multiply by 4. We're at 40 hairs. And then add on that extra hair from the very first month. And we'll be at 41 hairs. So for number 4, okay, the number of hairs on a Zorkian hairy Zyder can be written as a sequence 5, 9, 13, 17, 21. Drag tiles to complete the statements about this sequence. All right, this sequence is, I'll give you a hint, it's going to either be arithmetic or geometric. Who remembers if we're adding on 4 each time? You'll have to come off of mute and say it. No takers? All right, it is arithmetic because we're adding 4 each time. And the constant choices are going to be ratio or difference. Ratio goes with multiplication, difference goes with adding and subtracting. So the constant difference is 4 because we're adding on 4 each time. So on your paper for number 4, let's write these 2 sentences. The sequence is arithmetic. The constant difference is 4. Okay, those of you who are blowing up the chat, you must be pretty good at multitasking, writing down all these notes and typing into task or chat. So if you are not taking notes, then you're missing out on these points. So anybody who's getting annoyed with the chat, you can just exit out of the chat, or I might be able to turn it off. Okay, hopefully that helped. So, I mean, seriously, if you guys are not taking notes on this, and you're just goofing off, you're not wanting to do this assignment, then there's really no point in you being here. All right, for number 5. Assuming Zyders live long enough, how many hairs would be on the 100th Zyder? All right, so for number 5, we want the 100th Zyder. So we can do that just like we did for the 10th Zyder. It grows 4 hairs each month, so we can multiply by 4 and get to 400. And then we're going to add on that extra hair from the first month. So the 100th Zyder would have 401 hairs. All right, number 6. Maria and Gilbert are reviewing the integer multiplication rules. Help them complete the sentence below. When both factors are negative, the product will always be... What do you think? Yeah, you're right. So this was number 6. So they're talking about multiplication, and it's the same rule for division too. Multiplication and division. It asks when both factors were negative. When you have a negative times a negative, it's going to equal a positive. What about if you have a positive number times a positive number? What do you get? Positive. Mm-hmm. And then how about if it's positive times negative? Yep. How about negative times positive? Very good. Yeah. So when the signs are the same, a negative number times a negative number, it's going to end up being positive. Signs are the same. Answer will be positive. When the signs are different, a positive number times a negative number times a positive number, you're going to end up with a negative answer. Okay, number 7. All right, Julie is thinking about the product negative 54. Which expression could result in this product? Select all that apply. Okay, I don't want to have to flip back and forth between the screen. So let's just take a minute to write these down. So write down each one of those, the negative 9 times negative 6, and then what's underneath it, negative 3 times negative 3 times negative 6. Write all these down, and then we can decide which ones equal negative 54. Okay, so we're looking for answers that get us to negative 54. Negative times negative is going to be a positive So this one's a big fat no, because we are looking for a negative 54. Negative times negative gives us a positive, and then positive times negative will give us a negative. 3 times 3 is 9, times 6 is 54. So that works. Positive times positive gives us a positive. So this one's a no. Negative times positive gives us a negative, times a positive gives us a negative. 3 times 3 is 9, times 6 is 54. Positive times negative gives us a negative. And 18 times 3 is 54. Negative 3 to the third power. Okay, so negative 3 to the third power is going to be negative 3 times negative 3 times negative 3. And then we're going to be multiplying that times 2. So negative times negative gives us a positive, times a negative gives us a negative. 3 times 3 is 9. 9 times 3 is 27. And 27 times 2 is 54. Okay, number 8. Julie is thinking about which expression could result in the product negative 36. Select all that apply. Okay, take a minute and get these written down. Okay, we're looking for all of the answers that give us negative 36. So negative times negative gives us a positive. So this one's a no. Negative times negative gives us a positive, times a negative gives us a negative. 2 times 3 is 6, times 6 is 36. Negative times positive gives us a negative, and 6 times 6 is 36. Positive times negative gives us a negative, times a positive gives us a negative. 18 times 1 is 18. 18 times 2 is 36. Positive times positive gives us a positive, times a negative gives us a negative. 2 times 3 is 6. 6 times 6 is 36. Positive times negative gives us a negative, and negative times negative gives us a positive. So this will be a no. Negative times positive gives us a negative, and negative times negative gives us a positive. Negative 2 squared. So negative 2 squared means negative 2 times negative 2, which will be a positive 4. Positive times negative gives us a negative, and 4 times 9 is 36. Need another minute, or you guys got it? Remember, you have to have everything written down that I do in order to receive points. Okay. Brad wants to write as many multiplication and division equations that he can using only the numbers 6, 2, 3, and their opposites. Which of Brad's equations are true? Select all that apply. All right, let's just talk our way through this one. So we got to figure out if it's true or not. Okay, so we have a positive times a negative. That should give us a negative. So it looks like the first one is not true. And the second one, 6 divided by 2 is a negative 3. Positive divided by positive should be a positive here, so that one's not true. Okay, negative 6 divided by 2 is negative 3. Negative divided by positives is a negative, so that one should be true. So on your paper, let's write down negative 6 divided by 2 equals negative 3. And then negative times negative should give us a positive, so that one's not true. Let's go to the second column. Positive times positive gives us a positive, and 2 times 3 equals 6. So that one's true. So write down 2 times 3 equals 6. And then negative times negative gives us a positive, and 2 times 3 equals 6. So that one works also. And then positive divided by negative should be giving us a negative. So that one's not true. Negative divided by negative gives us a positive. That looks right. 6 divided by 2 is 3. So write down the last one. Negative 6 divided by negative 2 gives us a positive 3. Yep. Yeah, if you have both your phone and your computer going, you have to turn the volume down on one of them in order to not get the echo. Oh, I was on the other screen just telling you what to write down. So I'll leave my paper right here for those of you who need to copy it down real quick. You're welcome. And then did Dela, Suji, Stephanie, Edgard, Antonio, or Hayden never show up? Okay, Edgard, I gotcha. All right, let's go on to the next one. The difference between two negative temperatures is always negative. Oh, that's a tricky one. The difference between two negative temperatures is always negative. All right, so anybody know what difference means? It means subtraction. Okay, so we're going to be subtracting two negative temperatures. All right, we're going to be subtracting two negative temperatures. That looks really weird. I'm going to say we need to throw some numbers in here to see how this would work. Why don't we use, I don't know, some easy numbers here. Let's do a negative 10 minus, because we're finding the difference, negative 5. And when you have two negatives like that, normally you would put one of them in parentheses just to separate it out. Okay, so who remembers what to do when you have minus a negative? Mm-hmm. It becomes adding. So if you think of negative 5 as the opposite of 5, okay, so then think of this minus sign as opposite again. So what is the opposite of negative 5? It would be positive 5. So this becomes negative 10 plus 5. Okay, so if we're going down 10, but then up 5, where are we going to land? Go the other direction. Go down 10, but then up 5. Back up closer to 0. Negative 5, that's right. Okay, so for this example, we got a negative number. But it says, is it always negative? When you find the difference of two negative numbers, is it always negative? Will your answer always be negative? Think so? Okay, well, let's switch these around. Let's switch the 10 and the 5 around. So let's put the negative 5 first, and then we're subtracting out a negative 10. Okay, so if this becomes positive, we're going to have -5 plus 10. So here we're going down 5, but then up 10, or you could think of it as 10 minus 5. And what would we get? +5, yeah. So is the answer always negative? Nope. Okay, the answer is not always negative. All right, determine whether the following statements are always true, sometimes true, or never true. The sum of two positive integers is positive. So where we add two positive numbers together, are we always going to get a positive answer? Yes. Yes. So on your paper, I don't want to rewrite all these sentences. Okay, let's just shorten them down. The sum of two positive integers. So we're adding two positive integers. So why don't we just why don't we use variables and write P for positive? So on your paper, write P plus P equals P, meaning positive number plus positive number equals positive number. That make sense? Okay, so on your paper, this is what I meant. P plus P equals P, and P stands for a positive number. Okay, the next one is the sum of two negative integers is negative. Okay, so let's write N for negative, and this is the sum, so we're adding another negative number. So think about this on a number line. We have a negative number plus a negative number. So for the first negative number, we're going to be going down from 0, right? And then we're going to add on another negative number. That's going to take us even further down. So is our answer always going to be negative? You'll have to come off of mute because I can't see. No? So remember, two negative numbers. So we're going down below 0 and then down some more. It will always be true. It will always be negative. So on your paper, write N plus N equals N, and then write down what N means. N means a negative number. Oops. I don't know. I think it'll just go away on the next problem. Okay, the difference between two positive integers is positive. So difference, this is going to be subtracting. So the difference between two positive integers. So we'll say positive minus a positive. Is the answer always positive? Yep, maybe. This is going to be a sometimes true. Because if we say 5 minus a positive 10, well, 5 minus 10 gives us a negative answer. But if we do 10 minus a positive 5, 10 minus 5 would be 5, a positive answer. So this is, what did they want us to say? Positive? Yeah. So P minus P equals P sometimes. Not always. Okay, and then we have the difference between two negative integers is negative. Okay, so difference is going to be subtracting. So we have negative minus a negative equals negative. All right, let's play with this a little bit. Okay, so we've got a negative number. Let's go with like negative 2 minus another negative number. Let's go with negative 3. Okay, so remember, minus a negative is a positive, so we're adding. So this is like adding 3. So we'll have negative 2 plus 3, or 3 minus 2, which gives us 1. And the 1's positive, it's not negative. But if we switch these around, negative 3 minus negative 2. So this time we're adding 2. So negative 3 plus 2 will give us a negative 1. So this one is also going to be a sometimes. A positive integer minus a negative integer is negative. So positive minus a negative. What did you say? C. C is in yes. Positive minus a negative is negative. Okay, so let's play around with this. All right, let's use our 3's and 2's again. So positive 3 minus a negative 2, is it going to be negative? Minus a negative turns a positive 2, so this will be 3 plus 2, which gives us 5, so that's positive. So now let's try switching these out. So positive 2 minus a negative 3 minus a negative turns a positive. 2 plus 3 is 5. So either way, we end up with a positive 5. So this one is going to be never true. Is that all of them? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. All right, so on our paper, that first one checked out, second one checked out, and then it was sometimes, and never true. All right. Oh, and then it moves on straight into more practice. Okay, so let me stop the video real quick so I can separate these out, if it will stop.